Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so guys, before I forget, we have one more test this semester. So and we're going to start reviewing that test next week. So if you get your practice test done by Tuesday, then I will give you 10 points extra credit on your practice test and on your real test, okay? This is an important one. This is the last test of the semester, so make it a good one, finish strong, and we'll start reviewing that next week, okay? Can you guys do that? 10 points. It's awesome. All right, so let's do lesson 41. A lot of this will be more of a review, but so we'll just kind of go for it here. So let's label it nicely here.
Oh, did you start the recording?
Yes, thank you.
Okay.
All right, so this is 41. We're going to do a couple things. The first thing we're going to do is just evaluate expressions. That's some fancy words for just plugging in stuff and chugging it out. So plug and chug. Okay. So if, for example, if I have this expression, you guys know what this represents? You guys know what this formula represents? So A equals L times W. What does that sound like? Yeah, area equals length times width of a rectangle, right? So if you have a rectangle here and we've got a length, then we have W. So to find the area, we plug in the L and W. So this is what you guys do. So if I give you the length, if I say length is 8 and the width is 4, then you just plug it in. A equals 8 times 4, because you're just plugging 8 in for L and 4 in for W. And that's 32 feet. So square feet, right? Okay, you guys have done this before. You just plug in numbers and chug it out, plug and chug. Okay, well, there's another cool thing that happens here. If I were to find the perimeter, well, that is, let's see, that's L plus W plus L plus W. So you're just going all the way around the rectangle, right? Well, this could just be 2 times L plus W, right? Because there's an L plus W and there's an L plus W. So 2 times L plus W. Or it could be L plus L plus W, right? It doesn't matter what order you add the sides in, as long as you add all the sides, right? So this equals 2 L's and 2 W's. So this is a new property that I'm going to show you. This is called the distributive property. Distributive, when you think of the word distribute, you kind of, it could be like if I had a bunch of M&Ms and I was there and I distributed M&Ms. Remember we talked about average? Distributing means giving everyone the same amount or giving everyone a portion of the M&Ms, okay? So that's what you're doing with this too. You're going to distribute this 2 to both of these guys inside the parentheses. So you're not just multiplying 2 times L. You're not just multiplying 2 times W. You're multiplying 2 times L and you're multiplying 2 times W. So this is a good representation of the distributive property. And 2L and 2W, that's really what this is over here. So both of these mean the same thing. So 2L, 2 times L plus W equals 2L plus 2W. So this is just the distributive property, okay? Now, sometimes it's just easier just to add the L and the W and then double it. That's fine. but you can do it either way you want. Let's try it both ways. Let's say we've got another, well, let's just use this example. So if we have our rectangle, which is an 8x4 rectangle, if I want to find the perimeter, I can either just go 4 plus 8, then we're going to multiply by 2, right? So that's 2. So let's do that first. 2 times 12 equals 24. Well, let's try the distributive property and see if that works too. I could say 2 times 4 plus 2 times 8, which is 2 times 4 is 8. 2 times 8 is 16. 8 plus 16 is also 24. Okay, so either way, you get the right answer. Well, if these are numbers, I think I'd rather just add the 4 and the 8 together and then double it. That's what this is. But you could distribute that 2 to both. 2 times 4 is 8. 2 times 8 is 16, and add those together too. You get the same answer either way. Okay, so we've used this before. So when we do something like this, do you guys know what, let's see, 20 times 15 is? You know what you do when you actually, let's do 22 times 15. That's more exciting. 22 times 15. Can you guys do that in your head? Do you guys know how to do 15s in your head? Anyone know a trick? Well, here's my trick. I'm going to multiply the 22 times 15, which is just 10 plus 5. Right? Everyone realize that 15 is just 10 plus 5? So now if I multiply by 10, that's easy. I just add a 0, 220. And then I add 22 times 5, which is half of what it is times 10. So what's half of 220? 110. So those are easy addition problems. That's just 330. There's my answer. So that's kind of a fast way. So that's a distributive property. But if you did it this way, look, this is also the distributive property. If you multiply it out long ways, what you're doing first is you're multiplying 22 times 5, and then you're multiplying it times 10. 22 times 5. Okay, blah, blah, 110. And then you're multiplying 22 times 10. When you multiply by 10, you just add a 0. So 22 times 1 is 2 and 2. And see how we're doing the same thing anyway. We've been using the distributive property since first grade. When we do long multiplication, we multiply the top number times the 1 value, and then times the 10's value. And then we add them together. That's just the distributive property. It's just written a little different. Okay. So let's try another example or two. Let's see if you can find the perimeter, and you can do this however you want. I just want you to find the perimeter of this rectangle. Find the perimeter of this rectangle. Boom, boom, boom. So this is 30 inches by 20 inches. So you can try it both ways if you want, or just do it your way. Okay, so try it both ways. See if you get the same answer. Okay, so hopefully you guys are done. So all I'm gonna do is plug in my length right there. That's the 30. And I'm gonna plug in my width right there and see what I get. So I get P equals 2 times 30 plus 20. All right, well, that's nice. 30 plus 20 is just 50. Then 2 times 50 is just 100. Okay, and it's in inches, so 100 inches. All right, let's see if we get the same answer over here. Let's plug in the 30 and the 20 there, and I'll get P equals 2 times 30 plus 2 times 20. Let's do the 30 there. Let's see what happens. I'll get P equals 60 plus 2 times 20 is 40. What's 60 plus 40? Hey, it's the same answer. Okay, that's not too bad, right? Okay, so this is the distributive property. So if I used technical terms like this, if I said A times B plus C, that just equals A times B plus A times C. So that works with any numbers. So this is the distributive property. So you can write this down if you want. I don't think you need to know that word right now, but this is a good thing to know for your future as well. Distributive property. Okay. And it works the same way with subtraction too. So if I had a B minus C there, then it would be A times B minus A times C. Okay. All right. Does that feel okay? Any questions with that? You guys understand the distributive property? Let's just do one more. We're just going to do one more example just to drive it home. We'll try one with subtraction. So try this both ways. You can do what's inside parentheses first. That's what normal people do, but we're going to challenge ourselves and do this a little different. So we know that that's 15, and then 6 times 15 is 90. But let's do the distributive property and see if we get the same answer. Okay, so try that, and I'll be right behind you. Okay, so then I'm going to go 6 times 20 is 120. Minus 6 times 5 is 30. 120 minus 30 is 90. So see how that works? You get the same answer every time. This is a good way to check your work too. If you have a problem like that, you can check it both ways to see if you get the same answer. Okay. We're going to be doing a lot with the distributive property when you get to pre-algebra and algebra, mostly in algebra. But this is just a good little trick for you to know for now. It will help save time in a lot of ways. But yeah, so that's 41. You guys feel okay with 41? Distributive property, you good? All right, let's move on to 42. All right, a lot of you are familiar with this concept, and this is how you've been writing your division problems anyway, but we're going to talk about repeating decimals. Okay, so here's an example of a repeating decimal. If I wanted to convert 1/3 to a decimal, I would, well, how do you convert fractions to decimal? You just divide the top number divided by the bottom number. And 3 doesn't go into 1, so you add a decimal and a 0. 3 goes into 10 3 times. Subtract, multiply, subtract, bring down another 0. 3 goes into 10 3 times. Multiply, subtract, bring down another 0. 3 goes into 10 3 times. So this goes on forever, literally forever. So it keeps going 0.33333333. Okay. So instead of writing an infinite number of 3s on your paper or this little ... thing, we're going to use a symbol that says that 3 is repeated for eternity. So that's how you write your answer. And again, most of you know this, but it's a repeating decimal. Okay. Let's try some other examples. Let's say, and first of all, let me give you the official term so you feel important. The repeating digits of a decimal are called the repetend. So the 3 is called the repetend. Repetend. So that's the official word for that. Okay. And then we've got, yeah, so the repetend, blah, 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 the repetend one way indicate, okay. It doesn't give us the name, so I won't spoil it. I won't give you the name of the actual bar. It's a funny name, so I'm not going to write. But we just say bar. You put the bar over 3, okay? Because that's the number that repeats. Now, make sure you only put the bar over the number that repeats. Let's do an example of a decimal that you're not repeating all of the decimals. So let's try this division problem. 11 divided into 3.5. Okay. So try this on your paper and let's see what we get. And I'll be right behind you. Okay. I'm going to take a breath and then I'm going to jump in and catch up to you. Okay. So start doing this division. Okay. We're not dividing by a decimal. So I can just bring this decimal straight up. 11 doesn't go into 3, but it goes into 35 3 times. 3 times 11, 33, subtract 2. I can add as many zeros as I want after a decimal. So I'm going to bring down a 0. 11 goes into 20 just one time. 1 times 11 is 11, subtract. You get 9, bring down another 0. 11 goes into, let's see, multiples of 11s are double digits, so it goes in 88, so that's 8 times. 8 times 11 is 88. Subtract and you get 2, bring down a 0, and you get 20. Well, that looks familiar. I feel like I've done this before. Deja vu. What's happening? 11 goes into 20 one time. 1 times 11 is 11. Subtract, you get 9. Wait a minute. Something's repeating every time. I see what's happening here. It's math trickery. So it keeps doing that. So it's going to keep going 1, 8, 1, 8, 1, 8. So the only thing repeating is the 1 and the 8. So here's the wrong answer. Don't do this. That's not what's repeating. What's repeating is just the 1, 8, not the 1, 8, 1, 8, 1, 8, 1, 8, 1, 8. Okay. Don't do this. This is a misrepresentation of the answer. Okay. So all you're doing is rewriting just the 1, 8. So we're going to rewrite the answer 0.318. And then I'm just going to put the bar above the 1 and the 8. That's it. Okay. So don't put the bar across all the 1, 8s. Just pick 1, 1, 8. Even if you did this, this looks messy and gross like that. This is still the right answer, but I would rather have you rewrite it in a nice little box and say, this is my answer given to you. Thank you. Okay. All right. Let's do, yeah, so here's what your homework is going to be. Your homework is going to be easy. It's going to just say rewrite as a repeating decimal. Repeating decimal. So here's A. This is example 1. So I want to rewrite this in the right way, not with the ... stuff. So see if you can rewrite that as a repeating decimal in the right format. And then when you're done with that, try to rewrite this one. Okay, and then when you're done with that, try rewriting this one. Okay, so take another 30 seconds and write those repeating decimals. So write it in repeating decimal format. Okay, so here's what I got. I'm noticing that that 3 keeps repeating there. Okay, so I'm going to rewrite it. Everything on the left is the same, 0.08. And then I'm going to put the bar over the 3, but don't put it over the 8 because you're not repeating the 8. Awesome. All right, B is, it's a little bit harder to see, but I can see that it goes 1, 4, 2, 8, 5, 7, 1, 4, 2, 8. Ooh, there's the thing that repeats right there. So this is where it kind of breaks off, right? So I'm going to say 5.14285 7, and with the little bar above there. That's awesome. Okay. Anyone know what fraction that is? 142,857. This is a fun one. Let me see here. Let's try 37 divided by 7. That goes in 5 times. No, it's not that one. But it's close. When you divide by 7, it's can be a little tricky. 2, 14, that goes 6. It's 8, 56, 4, 5. Oh, I meant to say 6 there. Whatever. Okay, 285, so 35. Blah blah. So if that was a 36, it would have been 142,857. But when you divide by 7, it creates this crazy long repeating decimal. Okay, that's pretty fun. All right, what about C? So here's a common mistake. This is not what you do. You don't say 4, 5 like that. Well, that would be an infinite number. 4, 5 repeated would be 4, 5, 4, 5, 4, 5, and no decimal in sight, which would be an infinite number. That goes on forever. We don't want that. We're just repeating the decimal numbers that are being repeated. So we're just designating that. So everything on the left of the decimal stays the same. So all we're doing is repeating those decimals. So 5, 4, that's what's repeating, and that's your answer. Okay. All right. Now, here's a kind of a tricky thing, but the next part of your homework is going to be to round a repeating decimal. So I'm going to round. So here's example 2, and I'm going to round to the nearest, where am I rounding? Oh, we're just going to round to 5 decimal places. All right, so here's A. Here's what the first number looks like, 5.316. And the only thing being repeated is the 6. Okay, so if I round to 5 decimal places, I need to go 6 decimal places, because to round to a decimal place, you need to see what the next one is, because that next digit tells you whether to round up or keep it same. Remember, 5 or above, give it a shove, 4 below, keep it low. But you're not looking at the 5th decimal places to determine that. You're looking at the next one. So let's write out 6 decimal places. 5.316, 6, 6, 6. So see how there's 6 decimal places? Now I can round to this place. In order to round to that place, I have to look at the next digit. That's 5 or above. So I'm going to add 1 to that 6. 5.31667. So there it is, rounded to 5 decimal places. Let's see if you can do this one by yourself. Round this to 5 decimal places, 25.405 repeating. Okay, see if you can round that. Hold on, my kids are screaming. So hopefully they're happy screams. 1 second. They're fine. Rotten kids, goofing around, yelling and screaming. Okay, I'm going in. Here I go. Here I go. I'm going to just repeat a couple of those. It doesn't hurt to just repeat a bunch just so you have them. Okay, and then I'm rounding to the 5th decimal place. Okay, so 1, 2, 3, 4, 5. So I need to look at that guy, and that's 5 or above. So I'm going to add 1 to the circle digit. So 25.40541. That's it. Is that what you guys got? Yes? All right. Awesome. So that works. All right. Now this is, if you can do this problem, then you totally understand this lesson. Okay. So that is, so I don't want you to be discouraged if you can't get this problem, but this is putting everything that we've learned together. So here's what I want to do. So here's example 3. I want you to divide and then write the quotient with the bar over the repetent, and then I want you to round. Okay, so divide 1.5 by 11. Okay, and then I want you to write it as a repeating decimal, and I want you to round to the nearest hundredth. Okay, so round to nearest hundredth. Okay, so let's divide first. So 1.5 by 11. So remember, the first number goes on the inside of the box. I'm dividing. I'm not dividing by a decimal, so I can just move that decimal straight up. Add some zeros, whatever. How many times does 11 go into 15? Goes in 1 time. 1 times 11 is 11. Subtract, you get a 4, bring down the 0. 11 goes into 40 3 times. 3 times 11 is 33. Subtract, get a 7, bring down the 0. 11 goes into 70 6 times. 6 times 11 is 66 minus. Divided by, get a 4, bring down a 0. Okay, I think we're going to start repeating because I remember that 40. That goes in 3 times. 33, subtract, you get a 7, goes in 6 times. Okay, so this is what's happening. I am repeating the 3 and the 6. So my first answer, I'm going to write as a repeating decimal. So this is 0.136 with just the line over the 3 and the 6. If you put the line over the 1, that's the wrong answer. Okay, so now I'm going to round to the nearest hundredth. All right, so I'm going to first, what I need to do, hundredth is 2 decimal places out, so I need at least 3. Well, that works because that's just 0.136. I mean, you can add more if you want, but all I need are three digits because I'm rounding to the second digit. So this is where I'm rounding. So I look at the 6, it's above 5 or above. So that 3 goes up 1, so 0.14. So these 2 answers are acceptable. You should never round unless you're told to. But if it's an irrational number, which means it never ends and it never repeats, or if it's a repeating number, the more exact answer is this one, the one with the repeating, the repetend, okay, with the bar above the repetend. This is just an estimation, right? So technically you should write your answer. If you're going to round, you should write your answer like this. Instead of an equal sign, it should be an approximation sign, which is like an equal sign that just got flimsy. All right. So that's what an approximation sign is. All right. Now here's what else happens. Your calculator rounds automatically. So if you typed 2 divided by 3 on your calculator, you know what your screen is going to say? Your screen looks like this. Unless it's set at unless it's set at with fractions, your screen is going to look like this: 0.6666666. It gets to the end, so it rounds. That is not the answer to this question. Your calculator doesn't put a little bar above your thing. So what it does is it goes, I think maybe a lot of calculators have 8 spaces. So it goes to the end of the calculator and then it rounds. Well, but you don't have to worry about that anyway, because you're not allowed to use your calculator. So, okay. But if you see that on a calculator, that's what it's doing. It's rounding automatically. You didn't tell it to round. Your calculator is taking things into their own hands and think they can control the world. They can't. They're calculators. All right. So, but don't let a calculator tell you the answer. You need to know that first for yourself. Okay? You guys feel all right with this? Repeating decimals, dividing and rounding and repeating decimals. You guys feel good? Thumbs up, thumbs down. Okay, awesome. Good job, guys. All right, so you have about a half an hour to work on homework if you'd like. So, and don't forget, you can just get that practice test done by Tuesday for 10 extra points, okay? So work really hard and let Mrs. Powell know how many problems you do, and I'm gonna give you Flack Attack coupons for each one, all right? Now, so get 10 or more done, and you get a Flack Attack coupon for every 10 problems you do, okay? Good? All right, have a great weekend, and we will see you on Tuesday, okay? See you later.
Black math, give me some math and I'll give you some flack. Black math.